Just in, Tiger Woods scored a hole-in-one to win today's tournament. They say he was able to do this because the force of gravity and his perfect velocity created a magnificent parabolic path of the ball. Today's lesson is on factoring trinomials, specifically quadratics. All quadratic graphs create a shape similar to the path of Tiger Woods' ball that caused him to get the hole-in-one. Before I teach you how to factor trinomials, let's review how to FOIL. So we would FOIL when we are multiplying two binomials together. So let's quick review. FOIL tells us to do our first terms, multiply x times x is x squared, and then outside 6 times x is 6x, inside plus 3x, and last 3 times 6 is 18. And then we'd have to combine our like terms, so x squared plus 9x plus 18. So FOIL is when we were multiplying binomials. Today we're going to factor, which is basically undoing FOIL. So it's as if we are dividing. Instead, we're going to start with a trinomial and factor it into two binomials. What two binomials, when you multiply them together, will give you a trinomial? So previous lessons, we started with two binomials and our answer was a trinomial. Today we're just going to go backwards. We're starting with a trinomial and our answer is going to be two binomials. So we're going to look at this trinomial and we're going to pretend that we don't know where it came from. We don't know what two binomials it came from. But stop and think, where would it come from? Where did this 18 come from? 18 came from the multiplication of 3 and 6, so times. And then where'd that 9 come from? It came from the addition of 3 and 6. So that right there is very important to factor a trinomial. Our final answer will always be a set of two binomials like this, and we just have to think, how did we get x squared? Well, we did that when we multiplied our first terms together, x times x. And then how did we get 18? What two numbers together, when you multiply together, give you 18? Well, let's see, 1 times 18, 2 times 9, 3 times 6. So these are all possibilities of when you multiply together, you get 18. But which one of those, when you add them together, give you the 9? So it has to be this, plus 3 and plus 6, going backwards. Okay, let's do one more where we FOIL two binomials and then think about how you would go backwards. So real quick, g times g, g squared, plus 5g, plus 2g, and then plus 10. Well, combine like terms, so you can get g squared plus 7g plus 10. So there's our trinomial. Let's say that we started with this trinomial and we have to work backwards. We know that it's going to be two sets of binomials, and you have to think, what times what gives you g? Well, we know that g times g will give you g squared. And now, what are my factors of 10? Let's see, there's 1 times 10, and there's 2 times 5. But out of those factors, which one of them will add up to 7? Remember, you want two numbers that multiply to get 10, but add up to get 7. So we know it's 2 and 5. So we know that we would have to plug in 2 and 5. That is the basis of factoring. Alright, so here is a trinomial that we want to factor. When we want to factor, it just means we want to find out what two binomials, when you multiply them together, give you that trinomial. And the key to doing this is you want to find factors of c that add up to b. If you look at the top, this is just kind of a standard form of a quadratic. And we want to find factors of the number at the end, c, that add up to the number in the middle, b. In other words, what two numbers when you multiply together give you C, but when you add them together give you B? I always start by looking at the number at the end and thinking about all the numbers that when you multiply them together give you 30. And I just list them, list all the factors of 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Here are all my factors of 30. But you have to pick the set, which one of these sets adds up to 13. We can cross this one off, and this one off, and this one off, because 3 plus 10 is 13, and 3 times 10 is 30. So when we actually write in our answer, the first part here always comes from what times what gives you this. What times what gives you a squared? Well, a times a. And then you just take the factors that worked and plug them in. So plus 3 and plus 10. Because 3 times 10 is 30, and 3a plus 10a is 13a. Now, there's another way you can write the answer. It doesn't matter which binomial goes first. You can write a plus 10 and then a plus 3 if you want. I want to do 3 more problems together because some of these problems get a little bit tougher when all of a sudden not all the terms are positive. And then I'm going to give you 4 that I really want you to practice on your own. So, I know that my answer will be 2 binomials, and then I know that the first terms in each binomial will be what 2 variables when you multiply together give you y squared, and that is simply y times y. Now, to get my numbers, I have to find factors of negative 20 that add up to a positive 1. So, let's think about just factors of 20, and then we'll worry about the negative part. We have 1 times 20, 2 times 10, and 4 times 5. Well, because it's negative 20, that means one of these numbers has to be negative. So maybe it's negative 1 times 20, or 1 times negative 20, or negative 2 times 10, or 2 times negative 10, negative 4 times 5, or 4 times negative 5. So now we have to look at all of those factors and figure out which set adds up to a positive 1. We can cross these out and these out. So now we have to look at, well, one of these are going to work. Negative 4 plus 5, I think it's going to be this one because when they add up, they get a positive 1. Because the bottom one, 4 and negative 5, would add up to a negative 1, and we want positive 1. So negative 4 and a positive 5, when you multiply together, give you negative 20. But when you add together, give you a positive 1. So all you have to do is put those factors in your answer, negative 4 and positive 5. There you go. You have factored that trinomial into 2 binomials. Alright, the next one, x squared minus 18x plus 45. Let's find all the factors of 45. We have 1 times 45, 3 times 15, and 5 times 9. So these are my factors of 45. Which set of those adds up to a negative 18? Let's see. 1 and 45, definitely not. 5 and 9, definitely not. Well, here's 3 and 15. 3 and 15 add up to a positive 18, not a negative 18. So how are we going to make this work? Well, if you think, what is another way to multiply 2 numbers together to get a positive? They're either both positive or they both could be negative. Because a negative 3 times a negative 15 is a positive 45. But if you add 2 negatives together, you get a bigger negative, which would be negative 18. So my answer is going to be my 2 binomials where I start with x, and then just plug in minus 3 and minus 15. And we're done. Alright, so last one that we'll do together. Let's find factors of negative 18. When I'm finding factors and it's negative, I start out just by ignoring the negative, and let's just find factors of 18. So 1 times 18, 2 times 9, and 3 times 6. So now, since we want negative 18, let's just make one of these negative. And then you're just going to flip it. So you're going to have 1 times negative 18, 2 times negative 9, and 3 times negative 6. Look at all of those sets and which ones will add up to a negative 3. 1 and 18s, they're not going to work. 2 and 9, not going to work. So it's one of these involving 3 and 6. So, because we want them to add up to a negative number, that means the bigger number has to be negative, which would be this one right here. Negative 6 plus 3 gives you a negative 3. So my answer, 2 binomials. This time my variable is p, and I'm going to plug in plus 3 minus 6. And you can always check your answer by then just going through FOIL and seeing if you can get back here. 3 times negative 6 is negative 18. 3 plus negative 6 is negative 3. Perfect. So I want you to try these 4 on your own. So go ahead, pause the video, write them down, and try them on your own before you check your answer. Well, did you get them right? You did? News just in. You're amazing!